Okay, next up we have Bart Booij. Did I pronounce that correctly? Booij, okay. From TenneT. So Bart is a PAC engineer at TenneT, and I think he has quite a big task ahead of him. If from what I've seen, so was it something like 1400 or bays that need to be refurbished? So yeah, you have some work, and you're doing this with a standardized approach. So he's going to talk about why a vendor-independent SCT is necessary for standardizing our building blocks.
Okay, better. I took a bit liberal approach to the first title I gave you, so I don't know if we are exactly answering the question or but I think I still have quite an interesting talk. I hope so, at least. We had the safety, bit of an agenda, but you'll see what happens. Yeah, shortly. Who am I? A bit of an uncomfortable presenter at times. Maybe you can see at the picture. Worked for 5.5 years at TenneT now as a PAC, Protection, Automation, and Control Engineer in the standardization of the 61850 stations we are doing at the moment. I'll talk about that program a little bit more later on. And I worked for a few years, or 6 years, at some of the regional GSOs here in the Netherlands. Yeah, just some personal things. My wife, my 3 boys. That's a reason for a personal energy crisis once in a while. But luckily, I find time for some sports. And yeah, my history or my background is in geography, actually. So I made quite a change into this this technical world 10 years ago. But yeah, I like it. I'm still here. So I think the world likes me as well in that case. So shortly, the Bay Replacement Program, where I'm working for, together with Evert, sitting at the front here in Den Haag. We have 140 substations in the Netherlands that need to be renovated in the next 10 years. That's on the 150 and 110 kV level. We also have extra high voltage in the Netherlands, but that's out of scope. Our mission, well, I think I was watching the previous presentation, and I think a lot of the things that we want to do are the same as well. So we want cheaper solutions, quicker way of building new substations or renovating them. We have a graying populations, as we say, so people are getting older, getting out of the trade. So we need to use less people. And there was also a mission of unbundling from the DSOs because they were really intertwined. Well, and of course, we have to do it in a sustainable way. How do we do this? Compared to before at TenneT, where we picked out the components and just changed one by one, we try and redo the whole substation. So that's primary equipment and secondary equipment. Makes it a lot easier to standardize for secondary systems. Modular build is a way to do it. Highly standardized. We want to digitalize the substation, but also the information that we get from a substation should be more complete, I guess, for better maintenance strategies. Reduction in secondary cabling, use of plugs for the cables. I'll come to that later. And of course, 61850 as a new standard of information in the substation. Well, that all works out into a fast execution of our projects, predictable maintenance. The solution that was picked should be easily adaptable, expandable, and easy to refit at the end of life, and should be vendor independent. That's an important thing. Just a short movie about how this is done with the primary equipment. It's in Dutch, but I think the movie itself is more important than the text. So this is what they did in the primary way of working. Modular build, all primary equipment on what they call skids, and then drive them into the base for easy exchange if there is a malfunction or anything. I'll just look if you have a complete substation of that, like this. And the control cabinet where all the protection and control IEDs are in are, well, this is the closest for me, are in that cabinet. And there's a picture of it close to the primary equipment, because we don't use process bus. These are the main protection and control devices that are in here. It's outside, which was a major difference for our people on site. And is connected with plugs to the and standardized cables to the primary equipment, which means that it is prepared for automated testing. You can see a couple of my colleagues looking very interesting at the plug compartment of the cabinet. And because those plugs are standardized as well, we can use an automated testing cabinet with automated scripting to test the whole cabinet, and before they go on site, that is with the configured software, with 104 communication to the SCADA system. So one of the, hopefully ways in which a software or a PAC engineer does not have to go on site anymore. It's a bit about the primary things. Substation automation, what I am doing. We have 3 phases in our bay replacement program. Proof of concept phase, in which we ask 2 contractors to build from specification, from requirements, actually, a substation. So they could pick their own equipment and solutions. In the first implementation phase, we chose one of the 2 solutions to implement for a bit. You can see it in the middle. And now in our test facility, we have, with the TenneT prescribed products, we are building our own substation automation system and trying to standardize that. So these are the projects or the substations that are at this point somewhere in the bay replacement program. So some of them are with project preparation and some are already being built. So that's already quite a lot, and a lot of them are waiting for the standard that we are releasing quite soon. I think half of the green substations and all of the blue and purple ones that are at some point, being built with the standard that we are now developing. In the project, you have a typical phase, an execution phase in the factory, and an execution phase on site. And of course, I'm more interested in the typical phase. That is what we do at TenneT. The other 2 phases will be at the contractors and in the projects execution. So the engineering process for the whole secondary systems or the project, the protection automation and control system might not be top down per se. We try and look at what our contractors did in the proof of concept phase, what is already being done at TenneT, what can the IEDs do, for instance, and then we try and design our IEDs and our system from it. But I guess the 61850 engineering process really is top down. We use Helinks to do that, of course. Why else would we be here? But so what I said, we use station bus. I think our organization was a bit too traditional for immediate step over to process bus. But the first sounds are there, so that's good. But we did immediately go for Goose and MMS. a goose as well. So that's why we built a library in Helinks, but we also do that for our IEDs. So we have an Hitachi BCU and GE Micom BPUs, also from Siemens a few, and the Hitachi busbar protection. But because all these products are already tendered without 61850 in the specification, we cannot do a full implementation of our data model. We are I think we are quite good at looking at it pragmatically. So, okay, we have this situation where we can't do the ideal way, but we can make it work. And then next iteration, maybe we can make it even a little bit better. That's I think the approach that fits us very nicely. And then of course we have a network architecture with PRP network redundancy, and cybersecurity is obviously also a very important thing. So how are we doing a lot of these things? In our engineering process, we have a main focus on minimalizing the decisions that need to be made in an execution phase. So ideally, it's just drag and drop, copy paste, etc. for our contractors in the execution phase. All the difficult things, or signal lists, all the signal properties, all the goose templating, all the logics, everything should be done in our test lab in the typical phase. So that means we are maximizing templating, and we're using top-down engineering to achieve all those libraries. But it does result in developing our own namespace. I will get through a few examples later on. We are implementing flexible product naming with our Bay control unit. And we are maintaining a standard signal database within Helinks. And I think this leads to a substation configuration in the projects within a week. Easy exchange of signals with our SCADA team, our control center, and minimal pressure in the project on site. So what do you do the first day? I guess drag and drop your Helinks configuration. Do maybe change a bit base specific things. Figuring your signal list, then you go to your Bay control units, import the SCD. Do the same for your protection units, get all the parameters right. We can configure our substation HMI with just templating from an SCD, importing an SCD. We use the 80-1 for our 104 communication, for supplying the gateway with enough information. And in the last day, we have a maintenance server where we have it used as a tool server. So the Dixie and Helinks probably not. I don't know. No, that's for the engineers. And the other vendor tooling, we have syslog, airbag, all those kind of things on the maintenance server, which should be in a central location at one point, but that part of the TenneT organization is a bit late. But we're ready for it anyway. I want to try and let you see a little bit on how we are doing, what we are doing. So I'm trying to go to the tooling in a minute. We're using the IED crafter function at this point for configuring our Hitachi Bay controller. We can craft an IED from specification, give that to the tooling from Hitachi, and then the mapping between the Hitachi data model and the data model that we want is done in the Hitachi tooling instead of in the Helinks tooling, which in this case means that we can see our data model on the station bus, and the Hitachi data model is not adaptable, so that's what we prefer to do. but which also takes out the back loop. That's why I put 2 crosses in the model that I borrowed from one of your presentations. We don't have a feedback loop to Helinks from the Hitachi tool at this point. So yeah, I hope I can easily switch to the tooling in a bit. And I think I should share this screen, which is black. So yeah, basically we export our. Oh. In the meeting. Okay. Okay. Thank you. Then. Oh right. Am I sharing through Teams maybe or? Still.
Yeah, we can see the Teams.
Okay. Let's see. I will stop sharing in all places. Oh, I think I know what's happening. Let's see. Should stop the presentation. Now everyone here in Den Haag can also see what I was trying to show. Now, so we export our SCD file. We use the ID crafter function. So for the ones for the few people that don't know where that is, it's from this point. And then in the Hitachi tool, you map the IDs that are found in the SCD file with the internal IDs from the Hitachi tooling. And that's one of the unfortunate things. We can only, I guess, in a normal working day, we can only import an SCD file twice. Then time's up, because it takes a long time to import an SCD file. So you don't want to do this in the project execution phase. We try and get all the bumps away, and then we can template the mapping. So then for a project, it's just copy pasting and adding the correct template to the function. And this is not even importing. This is just opening up the mapping, basically. And then on the left-hand side, I have my data model from Helinks, the crafted IED for I should say. And then on the right side, there's the data model from Hitachi. And then we can just drag and drop all the signals on the right places, and which makes it so that the code we have for one of our busbar disconnectors is SRA, but in the Hitachi model, we can only see 1, 2, 3, 4, 5, 6, 7, 8, and everything else. So you just drag and drop the silo to the correct silo, and then you have your mapping ready. That's after we created our data model in Helinks. And let me quickly go back to the presentation for a bit. Yeah, so the second example that I would like to show you is our standardized signal list. We normal projects have their signal list in an Excel file, and you can adapt it by hand and then send it to the control system, and then you have you have this talk. Is it good? Is it not good? Is it the correct wording? And then there are other people who want different signals in the list. We work together with Helinks on getting our signal list into Helinks itself. So these are not the columns that you get out of the box. It's a custom way of working. I can just go and get any any selection of signals. And we at TenneT usually work at a bay level. So then I just click on my first bay. I click on the export button. I get an export. Just quickly, because I cannot find it any 25.317. This is something I'm still working on with your to get this out of the way, but this is just basically an error in the signal list template. There is one sheet, Excel sheet, which does not contain any columns, and then it goes through this error. It's just a beauty error. It's not a functional. Yes, it's not a functional error at this point. So. Yeah, then I should probably open this quickly and then share my screen again. Then the product is this list, which is still not fine for our control center. So I also built an Excel macro to get the sheets in the format that we like. Now it's good for our SCADA system, and it's good for the commissioning engineers on site, because they both, what Andrew already told in the first presentation, they both want different things. But it's on the same place. It's a single point of truth. It's all stored in our Helinks library, basically. So that then go back to my presentation. So is it fine on Teams as well? Yeah. Okay. Yeah, so this is the thing that I was just telling about. Yeah, some conclusions and things that we have challenged in the last couple of years. Yeah, the logical nodes and data objects do not always fit with what we want, because we have a traditional way of looking at a substation and the signals that are necessary for day-to-day operation. Not all of those signals are present in the standard 6150 model. But I think if you look at the previous presentation as well, there's something, you need to know 61850 before you can use it, but you also need to use it before you can actually know what the standard is. So what point are you starting on that circle? So I think at this point we are almost ready to release our first standard for the next projects. I think we can expect a lot of lessons learned from those first projects and develop our standard even more. Because we just want to get it working and get the projects on the move. Which is, from an engineering perspective, maybe not always ideal, but there's more people in the world than just engineers. And one of the questions we still have is how to verify and validate the use of our modules and standards. I think that's why Evert also asked the question before. How do you check if your contractors, if they didn't change anything to your standard? We try and find out what is a good data model for us. What do we need as an organization? What does maintenance need? What does commissioning need? What does operations need? And like I said, the real test is still to come when people like Sindhu and Andre are starting to use these libraries of ours. So when that comes, yeah, I hope we are ready for the future. So process bus is something that we really like to explore. Maybe get rid of some of our devices. There's more functionality into Base, and every functionality seems to need another device. We talked about point on wave before, an extra protection function. Why not use the IEDs that we are already here? It's a traditional way of thinking at TenneT, I think. And I borrowed a picture from the Bay replacement program. I think for us as at standardization of protection, automation, and control, learning to crawl, learning to walk, and learning to run. So I hope we now know how to walk, and in the future we might run. Yeah, get our projects done. Yeah. So thank you. That was my presentation. Just to get a quick sip of.
Thank you very much, Bart. That was very interesting. So let's start out. Are there any questions? Okay, go from the back.
Yeah, Anne van Berkel here. You talked about automatic testing. Do you involve Helinks also with that, or do you see a way these to involve 6150 in that sense?
No, at this point, the automatic testing is functional testing of the end product. So we do test. We do all that wiring testing. We do all the functional testing of the logics. We also we can also simulate the cross bay communication and communication to the gateway as well. So that needs 61850 obviously to work, but not per se to develop automatic testing. No.
Okay, thank you. Now, Andrew, you got a question?
Yes, not really maybe related to Helinks, but how do you get on with your external panels, just in terms of like weather environment, and what equipment have you got in those panels? Have you got IEDs in there, or is that just hardwired connections?
Yeah, the IEDs are in there. So there's close to the primary equipment, and then just fiber to the control room in the not really the control room, but the service building on site. The outside cabinets are a big discussion at TenneT at this point, to say the least. Yeah, we're struggling with some issues on the weathering and stuff, even though they have been tested for heat at least. I know there's some cabinets that are having problem with moisture, but yeah, it should be able to work.
That's very much the model we're looking at for the digital substation.
All right. Yeah.
And yeah, we're interested to see how that works out with all that similar environment and climate to we have here in Scotland.
Yeah, I think so. Yeah.
If you said as well, you're not doing process bus, but that's almost a process bus architecture you have there with that equipment out in the yard. So is it really just the implementation of sample values that you're not?
Yeah, exactly. Yeah, okay. That. Yeah, and I think I'm quite optimistic about the way forward, because we basically almost have a process bus architecture. People in the field already are already getting some experience with it. I think the next logical step would be process bus. Yeah.
Just finally, for your Goose, did you also use the application matrix within Helinks to configure all of that? Yeah.
Then a question is a comment that that's kind of a step approaching towards sample values of process bus. So that you can find in the market already that there's ideas that you can have side, and they are in pretty nasty environments in Asia. So in there are projects already with some running data that so it is a valid architecture, while you move the full step towards sample values.
Thank you. Any other question?
Or
Yeah, you mentioned for this phase at this phase, there weren't many 61850 specification during the tender for the IEDs and stuff.
Yeah.
How do you plan to do that in the future? Do you want to send out SSD files, ISD files, or how do you see it? Or
yeah, I think in the past we talked about sending SSD files to contractors, or to vendors, but I sometimes feel that the SSD file does not contain enough information for good tendering. At least we get products that maybe still not up to scratch for what we want, and so I'm almost thinking of just giving our entire data model as an SCD file into that. But of course, that's not mine decision, but still, because we know exactly what kind of signals we want, I think you should go a step further than SSD. Yeah.
Additional question, you also mentioned in your 5-day approach to configuring a substation, the first day also included configuring signal list. Is it the Excel export that you have?
That's just the Excel export. Yeah.
Okay.
Yeah.
For the rest, everything is built into
Yeah.
Helinks, right?
So we identified 4 typical bays, and the transformer bay where we connect to our DSOs. So the transformer is not actually from TenneT, but it's from the DSO. Has multiple configurations, for instance, and you should do some configuration in that bay. Probably delete a few objects, and then also look at the signals, of course, if that's correct. Yeah.
Okay, but everything is then done in Helinks. You just have to export it and run the macro for a TenneT signal list.
Exactly.
Okay.
Yeah.
Okay, thank you. There's a question online.
Mm-hmm.
This is from Pert Benjamin. Sorry for butchering the name. Are you renovating stations bay by bay, or would you always tackle a station as a whole? In the former case, do you have any pointers on keeping a station that is then not fully digital running during a renovation project?
We have multiple scenarios, but the bay by bay approach, or we try and group a few bays. We have not tried yet, so. But Sindhu is working on it. I hear from my colleague, so maybe she can explain. But yeah.
In our case, at least how we have thought about it, we've still not executed is to keep it as an old substation with some interfaces to the new substation. So the bay by bay approach, the bays that are in 61850 will be considered a partially new substation with hardware interfaces to the old substation.
All right. Yeah.
Yeah. So that's how we have envisioned it right now.
Yeah. Sounds logical.
Okay, thank you. Any more questions? Then I have a small question. You showed the process of exporting an SCD with an ID data model in there that you then load into the Hitachi tool, and then you map it to the internal Hitachi data model. So is this mapping stored in the Hitachi tool? That means if you give it another SCD with the same crafted IED, then you don't have to redo the mapping. Right?
Yes.
And this crafted IED that you have in the SCD, that's already configured as well. So you're basically building your own IED. You have control blocks, data sets, extras, everything in there. In Hitachi, they can just deal with that.
Yeah,
and
exactly. Yeah. Oh, but I see my colleague Evert jumping on his chair. Yeah.
The mapping in Hitachi can be exported as XML, so it's also version controlled. The only thing we do is the later binding. You have to set the crosses in the Hitachi tooling. That's the only thing which is not automatically.
Yeah. So the tooling does not get the later binding directly from the SCD file. You have to do one manual thing. But that's also not templated?
would that be possible to include in the SCD file if you manage to generate XREFs in Helinks that already have the appropriate int addresses that we would have to know, of course. We'd have to have some insight into how Hitachi does it.
Yeah.
And then that step could also be automated. Do you think that would be possible?
It's worth looking into. Yeah.
Might be another thing to automate.
Yeah.
Okay. I think, Andre, did you have a question or did I? Yeah.
Now you're doing this flexible naming for the bay controller.
Yeah.
And I think that's just by coincidence. Now this is something you want to move forward into all IADs.
Yeah, I know that that our SuperTech devices also support this, so we can do it as well over there. But at this point, we cannot do it with the GE devices. So, yeah, it's what we want. So yeah, we want to do it across all IADs. Yeah.
Yeah, that's very interesting. I hope that this is really the trend, because I think it's incredibly cool that we can cut out this whole process of getting the ICD, getting maybe an IID iteration into the SCT, and the SCG just does the engineering, and the vendors just know how to deal with it. That'd be great.
Yeah, exactly. Yeah.
Okay, are there any more questions? Okay, then I have one more question. Is there any way to get one of those Lego sets that you had in the movie? I know you showed them to me in person. I don't know if there's a kind of gift shop or something.
Unfortunately.
Yeah, that's
Maybe.
something to think about. Maybe
Yeah.
It would be a great goodie also.
Yeah.
Yeah,
I know.
Okay.
Yeah.
Okay.
There's already a second batch of Lego models, I think.
Right. Okay. Great. Okay. Thank you very much, Bart.
Yeah. Thank you.
Of course, the obligatory cutting board and cheese grater. Although being Dutch, you might maybe already have a cheese slicer. I don't know.
But not of Den Haag, and certainly not
and
with my name on it.
Your name
so-
on it.
Yeah,
so-
nice. Thank you.
Das Verspielen. Okay, and we are off now for a coffee break, right? And we are reconvening at 3 p.m. and then we'll hear from Keith Gray. Okay. 30 minutes from now. Yeah.